For as modern as America's national defense is, there is still a large reliance on equipment that is decades old. The B-52 Stratofortress, the CH-47 Chinook, and the M61 Vulcan are all still in service, all predating man's first steps on the moon. The reason is simple. They're still effective, but maintaining equipment that old can be a challenge. Parts that were once easy to get are now sparse, or in some cases, no longer being made. But there is a solution, one that America's military is quickly adopting: additive manufacturing. To the casual observer, additive manufacturing might look the same as 3D printing, but there is a slight difference: scale. Essentially, it's the difference between printing a chess piece at home and creating a ball valve destined for a Navy vessel. For example, printing this hunk of metal, then machining it into a finished piece ready to be installed on a submarine. Andy Feaster of Fairbanks Morse Defense told us using traditional means to get the same part could take somewhere from 6 to 36 months.
Big innovation with that, I can get that in 6 weeks. I'm going to get it in 6 weeks every single time. If I need it faster, I can even get it faster. And I know what I'm getting is good. I might have to put a little more machine time in it, to take it down to what I see here, but it gives me that predictability and allows me to schedule and plan my work and increase our efficiency within our manufacturing environment.
It's the kind of efficiency that's making believers out of anyone involved in the process of getting a boat in the water or an aircraft back in the sky.
We like to say valves are, big enough to be important, but not so big to drive the price of a boat. However, when you can't deliver a valve or when you can't deliver a piece part, that can drive the schedule for a ship and delivery of the ship to the Navy, which ultimately is one of the biggest cost drivers of these large programs. So anything we can do to get our customers and the warfighter what they need when they need it is really going to help the supplier industrial base deliver on what the Navy needs.
Meeting those needs is important enough that now each branch of the DoD has ways to take the process out of the factory and into the battle space. For the Marine Corps, that means turning additive manufacturing into expeditionary manufacturing, taking the process to where it's needed the most.
Now, not only are we focusing on parts that are made out of plastic, we're also focusing on parts that are made out of metal. So one of those examples would be the fuel glass. We had one that broke, and they brought it to us, and we metal 3D printed it.
Not to be outdone, the Army embraced the process as well. This is time-lapse video of the largest U.S. Civil Works component ever produced by additive manufacturing. It's a Poe lockship arrestor used to safely and quickly halt a 100,000-ton vessel. Using conventional manufacturing would have taken 18 months. With additive manufacturing, it was done in 12 weeks, allowing the Soo locks between the Great Lakes border of the U.S. and Canada to reopen in March of 2024. The Air Force is getting in on the action too. In 2018, Hurricane Michael flattened parts of Tyndall Air Force Base in Florida. The devastation was so complete, the base is still rebuilding much of what was lost. In 2023, that included this printed facility for robotics research. It's the first of its kind on an Air Force base anywhere in the world.
It does meet the new Unified Facility Criteria, which is the military building code for 3D printed structures, but this is the first 3D printed building that we know of, especially in the military, that actually meets what's called the Miami-Dade wind code standards.
It's a trend that shows no signs of slowing down. According to Vantage Market Research, the additive manufacturing industry was valued at $14.5 billion in 2022 and is projected to reach a value of more than $69 billion by 2030. The DoD's challenge now is widespread implementation, building the infrastructure that will allow additive manufacturing to shorten supply chains and keep American troops in front of their near-peer adversaries.